Have you ever truly tried to wrap your mind around the absolute scale of the cosmos? At first glance, calculating the dimensions of space seems straightforward. Yet there is a deeply disturbing truth hiding in the math. The moment you step back and genuinely contrast the sheer vastness of celestial bodies against one another, a terrifying reality begins to take shape. Every single glowing ember in the night sky, every sprawling galactic neighborhood, and every supercluster combined accounts for a mere fraction, under 5%, of the actual cosmos. Our entire observable reality is nothing but a microscopic speck drifting through an endless, unimaginable void. Stick with me over the next few minutes, and you will finally grasp the mind-bending proportions of our reality, alongside the haunting possibility that everything humanity has ever witnessed is merely a drop in an infinite cosmic ocean. Just a quick pause before we launch into the dark. If diving into the spectacular mysteries of astrophysics sparks your curiosity, hitting that like button and joining our subscriber community means the world. Those small clicks fuel our algorithm, allowing these astronomical journeys to find fellow stargazers across the platform. All right. Let us ground ourselves first with a reference point we all know intimately. The pale blue dot we call home stretches roughly 12,742 kilometers from one side of the equator to the other. To put that in human terms, marching around the globe for 8 hours a day would consume well over 365 days of your life. Even if you floored a car on a hypothetical global freeway without ever hitting the brakes, the journey would drag on for 14 relentless days. Looking out your window, this rock seems impossibly vast. It is packed with towering peaks you will never scale, endless stretches of deep water you will never sail, and foreign lands that will remain forever unseen. We struggle to genuinely process the magnitude of our own globe purely because our daily lives are confined to such minuscule geographic pockets. Yet in the grand cosmic arena, our world is essentially dust. We share our immediate neighborhood with a family of 7 distinct planetary bodies, locked in a gravitational dance around a fiery core so gigantic you could stuff 1.3 million copies of our world right inside it. The Sun boasts a terrifying diameter of 1,392,000 kilometers, dwarfing us by a factor of 109. Imagine treating our massive, seemingly endless planet like a bead on a string. You would have to stack 109 of those beads in a row just to span the blazing face of our local star. However, as mind-blowing as these physical dimensions are, the empty spaces separating these worlds are vastly more intimidating. Our comfortable orbit keeps us parked roughly 150 million kilometers away from the blazing inferno, establishing the standard cosmic measuring stick known as 1 astronomical unit. Even the ultimate speed limit of the universe, photons blazing at 300,000 kilometers per second, requires an agonizing 8 minutes and 20 seconds to bridge that gap. You are literally feeling the ghost of a star from an eighth of an hour in the past, entirely detached from the actual present. Moving further into the dark, we encounter the gas giant Jupiter, an undisputed heavyweight champion lingering 5.2 astronomical units out, translating to a staggering 778 million kilometers in the distance. The radiant energy from our star exhausts 43 minutes just traveling through the freezing vacuum to illuminate its swirling storms. Out at the freezing fringes, Neptune silently patrols a track 30 astronomical units away, keeping a staggering 4.5 billion kilometers between itself and the center. A solar beam fired toward this icy blue guardian takes 4 solid hours to finally arrive. Yet the story of our cosmic backyard does not conclude with the 8th planet. Pushing much deeper into the pitch-black frontier reveals a mysterious territory known as the Oort cloud. Think of it as an immense frozen bubble packed with ancient comets, acting as a giant vault enclosing our entire stellar neighborhood. This icy shell begins around 2,000 astronomical units out and stretches a phenomenal 100,000 astronomical units away, establishing an outer frontier nearly 1.6 light-years from home. To fully appreciate that scale, a single light-year equals the ground a photon covers in 12 months. An agonizing 9.46 trillion kilometers. The very fringes of this frozen wasteland represent the ultimate finish line of the sun's magnetic leash, the final outpost where rogue debris still answers to the weak, fading gravitational pull of our parent star. Have you ever truly tried to comprehend just how terrifyingly empty the universe actually is? Because the icy boundary known as the Oort cloud stretches practically 50% of the way to our closest stellar neighbor. That next-door neighbor happens to be Proxima Centauri, locked in a gravitational dance with two other stars in the Alpha Centauri system. It hovers roughly 4.24 light-years from us, which translates to a mind-boggling 40 trillion kilometers through the void. Imagine booking a flight on a standard passenger plane to go check it out. Cruising at 900 kilometers per hour, you would be staring out that window for an agonizing 5 million years. It is nearly impossible for the human brain to grasp those numbers. So let us shrink things down a bit. Picture our massive sun as a standard basketball, measuring 24 centimeters in diameter. On this exact same scale, our entire world becomes a microscopic bead spanning a mere 2 millimeters. So, where do we place this speck of an Earth? Definitely not hovering right beside the ball. You would need to walk 26 meters away, roughly equivalent to parking a pair of yellow school buses bumper to bumper. Just like that, the sheer desolation of our cosmic neighborhood starts sinking in. Now, let us try adding Proxima Centauri to this miniature universe. Do we put it across the street? Not even in the same town. You would literally need to journey nearly 7,000 kilometers. If you left your sun basketball sitting on the streets of London, you would have to fly all the way to New York City to drop down the next star. Picture that. A pair of sporting goods divided by the entire expanse of the Atlantic Ocean. Keep in mind, this represents the absolute tightest gap between stellar neighbors. The vast majority of them are scattered unimaginably further out, which is the foundational reality of cosmic geometry. These celestial bodies float in absolute isolation, separated by gulfs so immense that even photons, the fastest entities in existence, require years just to bridge the gap between them. Yet, this lonely star of ours is merely a single point of light among hundreds of billions composing our local cosmic city. We call this glittering metropolis the Milky Way. A spectacular barred spiral structure packed with anywhere from 100 billion to 400 billion glowing orbs. Why such a massive margin of error? Because tallying up a system from the inside is an absolute nightmare. Imagine being dropped deep into a massive jungle and being asked to catalog every single tree towering around you. The immediate surroundings completely obscure your vision of the distant horizon. However, pinning down an exact figure is entirely secondary to grasping the sheer magnitude of it all. We are talking about billions upon billions of stellar islands, floating solitary in an ocean of absolute nothingness. Spanning roughly 100,000 light-years from edge to edge, our galaxy is a mere 1,000 light-years deep, flaring out significantly right around its core. Should you somehow manage to gaze at this colossal structure from a side profile, it would resemble a flattened record with a swollen center. We are located about 26,000 light-years away from that chaotic heart, tucked neatly at the midpoint toward the outer perimeter in a remarkably quiet galactic suburb between sweeping lanes of dust and gas. And this entire structure is spinning wildly. Our whole solar neighborhood careens around the core at roughly 828,000 kilometers per hour. Yet, despite cruising at that blistering pace, a single lap takes us an astonishing 225 million years to finish. To put that timeline in perspective, the last time we occupied this specific patch of galactic real estate, the first dinosaur had not even hatched. Our world was. Locked deep within the Triassic era, its land masses completely fused into a single, colossal supercontinent, known as Pangaea. Ready to expand your mind even further? Our cosmic city is not drifting in isolation. We belong to an intimate galactic neighborhood known to astronomers as the Local Group. This community houses roughly 50 distinct star systems, although the vast majority are simply tiny dwarf formations. The heavyweights ruling this sector are us, the massive Andromeda system, and the stunning Triangulum galaxy. Towering above them all is Andromeda, a leviathan holding close to 1 trillion stars and stretching a staggering 220,000 light-years across the void, making our spectacular Milky Way simply the runner-up in this cosmic heavyweight division. Then you have the Triangulum galaxy, kind of the little sibling of the group, holding roughly 40 billion stars. Have you ever tried to visualize the sheer, terrifying emptiness between our Milky Way and Andromeda? It sits a mind-numbing 2.5 million light-years away. Let that truly sink in. Even a photon rocketing through the void at 300,000 kilometers per second needs 2.5 million years just to cross that cosmic bridge. Suppose you could somehow break the fundamental rules of physics and surf the cosmos at light speed. You would still be staring out the window for 2.5 million years before arriving at your destination. Now, strap yourself into humanity's fastest probe, Voyager 1. Cruising at a blistering 61,000 kilometers an hour away from our sun, that exact same trip drags out to roughly 44 billion years, tripling the entire lifespan of our universe. Zooming out, our cosmic neighborhood, the Local Group, stretches across a dizzying 10 million light-years of empty space. Strangely enough, on a universal scale, this galactic gathering is actually considered pretty tiny. Other regions of the cosmos cram thousands of massive galaxies into that exact same amount of real estate. Yet, wrapping your head around a 10 million light-year void is practically impossible for the human brain. Let's scale it down. Imagine our entire Milky Way shrinks to a standard 25-centimeter dinner plate. In this miniature model, our Local Group spans a room-sized 2.5 meters, while Andromeda is just another plate sitting roughly 63 centimeters from your hand. Hold on tight though, because the rabbit hole goes much deeper. Our little neighborhood gets swallowed up by an unimaginably vast web known as the Virgo supercluster, or Laniakea. Picture a staggering 100,000 galaxies glittering across a tapestry 520 million light-years wide. Rooted in the Hawaiian language, Laniakea brilliantly translates to immeasurable heaven. It is the absolute perfect title for this cosmic behemoth, considering it took hundreds of dedicated astronomers, decades of relentless observation just to sketch its boundaries. Laniakea is far from a chaotic jumble of drifting star systems. It acts like a massive, living organism bound tightly by gravitational forces, where every single galaxy is constantly in motion. They drift like glowing rivers along invisible cosmic threads and vast structural walls, all relentlessly dragged toward a mysterious, terrifying focal point we call the Great Attractor. Lurking somewhere out near the Centaurus and Hydra constellations, this gravitational monster is violently warping our universe. It is reeling in the Milky Way, along with countless other galaxies, at an unbelievable 2 million kilometers an hour. The craziest part? Science has absolutely no idea what this thing actually is. It sits directly behind our galaxy's incredibly dense center, completely blocked out by thick clouds of stellar dust and blinding starlight. Peeking at it through our current telescopes is fundamentally impossible. Its existence is only betrayed by the wake it creates. We track the weird gravitational currents of neighboring galaxies and trace them back to the source. Whatever monster lurks in the dark, it wields the sheer heft of tens of thousands of individual galaxies. Could it be a colossal clump of dark matter? Or perhaps an incredibly dense supercluster totally eclipsed by our own cosmic backyard. Take a deep breath and look back at the trail we just blazed. Launching from our tiny pale blue dot, we vaulted past the solar planets, leaped across the Milky Way, navigated the massive expanse of our local group, and dove headfirst into Laniakea, watching 100,000 glittering galaxies cascade toward an invisible abyss. Yet, mind-bendingly enough, Laniakea is merely a single drop in an ocean of millions of similar structures scattered across the dark. Which brings us to the observable universe itself. A bubble infinitely more gargantuan than your intuition suggests. The ultimate boundary out there is known as the cosmic horizon. That is the absolute furthest a photon could fly since the dawn of time. And our cosmos clocks in at a ripe 13.8 billion years old. Logic tells you our visual bubble should extend exactly 13.8 billion light years in every direction, right? Wrong. Ever since the explosive birth of the cosmos, reality itself has been stretching outward. Worse still, somebody stepped on the cosmic gas pedal. That expansion is continuously speeding up. The very fabric of space is unspooling, physically dragging ancient galaxies away from our eyes at terrifying velocities. Factor in that aggressive stretching, and the true radius of our observable realm blows up to a jaw-dropping 46.5 billion light-years. Have you ever tried to wrap your mind around the true scale of reality? We are talking about our visible cosmic sphere, stretching roughly 93 billion light-years from end to end. In standard measurements, you are looking at 880 billion trillion kilometers. A figure so absurdly massive, it completely shatters human logic. Honestly, our primate brains simply were not wired to process this level of enormity. Sure, astrophysicists can crunch the equations and jot down the zeros, but actually picturing that vastness? It is practically impossible. Now brace yourself, because the situation is about to get significantly weirder. Scattered throughout that colossal void are roughly 2 trillion separate galaxies. Researchers arrived at that staggering calculation by staring into the darkest patches of the night sky using humanity's most advanced orbital telescopes. And tucked inside every single one of those galactic hubs are hundreds of billions of burning suns. Let us try a little thought experiment to anchor this in reality. Cue the dramatic soundtrack, or at least try to prevent your brain from short-circuiting. Imagine shrinking our entire visible cosmos down to the size of planet Earth. That is a globe exactly 12,742 kilometers wide. On that radically shrunken scale, our grand Milky Way would shrivel down to a microscopic 14 micrometers, barely the width of 2 red blood cells. Without technological help, our entire home completely vanishes from sight. You would literally have to slide our galaxy under laboratory glass just to spot its glowing edges. Keep in mind, that tiny microscopic speck holds billions upon billions of solar systems. So every single star, including the one warming your face right now, would shrink down so infinitely small that even humanity's most advanced electron scanners could never detect them. Not clicking yet? Let us try a different visual. Picture our entire home galaxy as a standard 2-centimeter coin. In this scenario, the visible cosmos explodes outward to a span of 2,000 kilometers. That is effectively the span of a road trip from Los Angeles all the way to Denver, or hopping a flight from London to Rome. Picture yourself standing on a California sidewalk, gripping that tiny coin containing every star you have ever known. And in that moment, you realize the space all the way to Colorado is packed with trillions of identical coins, stretching in every conceivable direction, each representing another galactic empire. Hold on tight though, because that mind-numbing expanse we just talked about, that is not even the whole picture. That is merely the section illuminated to us. The true fabric of reality is undeniably vaster, perhaps lacking any boundary whatsoever. Our visual horizon only marks the edge of ancient light reaching our telescopes, not a physical brick wall at the edge of existence. Lurking in the dark beyond that threshold lies an untold expanse of unmapped space, filled with countless more worlds. They remain cloaked in shadow simply because the photons they emit have not had enough time to cross the void and hit our lenses. So, what is the true scale of creation compared to our little pocket of visibility? The honest truth is, nobody knows for sure. It could be double the size. It could easily be 1,000,000 times more expansive. Or it might just stretch on without an end. Modern astronomical data heavily hints that the fabric of space-time is exceptionally flat, and a perfectly flat plane rolling onward forever aligns flawlessly with every mathematical model we possess. Should reality truly hold no borders, then everything we have ever mapped out, despite its staggering scale, becomes functionally equivalent to zero compared to the infinite whole. We are nothing more than an insignificant, microscopic droplet lost inside a boundless, dark ocean. Let the heavy weight of that concept sink in for a second. Every single gleaming point of light you stare up at on a clear midnight, every majestic spiral captured by billion-dollar orbital cameras, every grand cosmic web, from our local group to the massive Laniakea supercluster, is trapped inside our little viewing sphere. And just outside those invisible walls lies an eternal, unfathomable abyss. A realm choked with foreign solar systems and untouched planets we are completely blind to, destined to remain forever hidden because their light will never outpace the expansion of space. But hey, let us refocus on our own local patch, because frankly, even that is enough to leave anyone entirely breathless. Have you ever paused to wonder if our universe has an actual shape? For decades, cosmic cartographers have dedicated their lives to mapping the grand architecture of reality, tirelessly piecing together the ultimate cosmological puzzle to uncover exactly where these glittering star cities reside and how they weave together across the endless dark. The grand reveal? Space is far from a smooth, featureless ocean. Star systems are not just tossed around blindly like salt sprinkled on a table. Instead, they form mind-bendingly colossal tapestries that completely defy human scale. Much like people flocking to bustling metropolises, galaxies huddle tightly together into sprawling cosmic neighborhoods and massive city-like swarms. Our very own Milky Way resides in a quiet little cul-de-sac we simply call the local group, which is basically a tiny galactic village compared to the truly gargantuan cosmic megacities out there. Take the Coma cluster as a prime example. It is bursting with more than 1,000 massive galactic hubs and likely 10,000 tinier satellite systems, all crammed together within a cosmic boundary spanning roughly 20 million light-years from edge to edge. Then there is the Virgo cluster, sitting right next door in astronomical terms at a mere 54 million light-years distant, playing host to anywhere from 1,300 to over 2,000 sparkling star realms. But the scaling up does not stop there, as these huge galactic cities naturally merge into sprawling nations of stars, known as superclusters. We have previously explored the breathtaking Laniakea, the magnificent super empire our galaxy calls home. Yet it is merely one among millions of similar titans strewn across the entirety of the cosmos we can actually see. Every single one of these behemoths harbors tens to hundreds of thousands of entire galaxies within its powerful gravitational embrace. The Shapley supercluster stands out as an absolute monster of cosmic architecture, holding the title as one of the most massive formations ever detected. Sitting roughly 650 million light-years off in the distance, it binds together over 8,000 separate galaxies. Yet remarkably, even these superclusters link together to forge utterly staggering formations dubbed filaments and walls. Imagine vast, glowing threads and sweeping cosmic spiderwebs spun from pure starlight, radiating out over hundreds of millions or even billions of light years in length. Just look at the Sloan Great Wall, a jaw-dropping marvel identified back in 2003. This specific cosmic thread snakes through space for a mind-numbing 1.37 billion light years. Floating 1 billion light years away from our home planet, it acts as a gravitational anchor for tens of thousands of galactic communities. To really put that into perspective, if our entire Milky Way galaxy suddenly shrank down to a simple grain of rice, measuring just 2 millimeters wide, the mighty Sloan Great Wall would stretch past 10 standard football fields, lined up consecutively, spanning a whopping 1,100 meters. And miraculously, that is merely a single thread in the tapestry. Countless similar titanic ribbons are interwoven throughout the deep, dark cosmic ocean. Yet the ultimate heavyweight champion of the cosmos is a structure crowned the Hercules Corona Borealis Great Wall. Macro through intensely violent bursts of gamma radiation, this glowing anomaly points toward an impossibly dense congregation of star systems extending over a mind-boggling 10 billion light years. Let that sink in for a second. That single structure claims more than 10% of the entire observable universe's width. Its very existence is a total cosmic rule breaker, completely tearing up our current textbooks on how reality supposedly grew and took shape. If you trust standard astronomical blueprints, a beast of this magnitude literally should not be possible. Gravity simply has not had enough ticks on the cosmic clock since the Big Bang to construct something this impossibly huge. And yet, there it sits, staring right back at us. Its undeniable presence leaves us with two thrilling possibilities. Either our scientific rulebook is fundamentally flawed, or some hidden mysterious force is secretly pulling the strings of the universe. Carved out between these radiant, glowing spiderwebs lie the darkest, emptiest places imaginable. The immense cosmic voids. These are terrifyingly massive dead zones where almost no light dares to shine. Take the Boötes Void, a shadowy expanse mapped out in 1981. It forms a giant, hollow-looking bubble expanding roughly 330 million light-years wide, with hardly any stellar occupants to speak of. While it is not a perfect, absolute vacuum, it is profoundly deserted and incredibly barren compared to your typical stretch of deep space. In a chunk of space that massive, you would easily anticipate finding around 2,000 thriving galactic cities. But the Boötes Void barely manages to scrape together a measly 60. Have you ever tried to picture true emptiness? Because these cosmic dead zones make the colossal threads and barricades of galaxies look easy to wrap your head around. We are talking about jaw-dropping stretches of the cosmos where absolutely nothing lives. Imagine a barren wasteland stretching continuously for hundreds of millions of light years in every possible direction. If you magically woke up right in the dead center of one of these lonely voids, your night sky wouldn't have a single star or spiral shining back at you. The closest neighboring star cities would sit so incredibly far off that your eyes could never pick them out. Even if you peered through the most advanced observatory equipment ever built, you would find yourself completely swallowed by an ocean of pitch black, save for a ghostly distant haze marking the boundaries of your bubble. When you zoom all the way out, the grand architecture of our cosmos actually resembles a gigantic, glowing spiderweb. Thick ropes and vast barricades of star systems wrap tightly around those unimaginably huge pockets of absolute nothingness. Think of it like a massive sponge or soap suds in your kitchen sink, where all the gleaming star cities are crammed into the paper-thin skin separating giant, hollow bubbles. How did this happen? It took an immense stretch of time, billions of years, for gravitational forces to sculpt this majestic design by slowly dragging material into clumps. Right after the dawn of time, the cosmos was essentially a smooth, even soup of stuff, sprinkled with just the faintest microscopic ripples of thickness. Yet those microscopic bumps were the ultimate seeds of creation. The slightly thicker patches commanded a tiny bit more gravitational pull, which sucked in neighboring dust and gas, snowballing into heavier and heavier anchors. Fast forward through eons of cosmic history, and that runaway snowball effect carved out the spectacular, sprawling galactic tapestry we observe right now. But what if I told you we are completely blind to the main event? Because no matter how mind-blowing our visible cosmos might be, and the vast majority of reality is made of a ghost-like substance, an invisible player we cannot observe firsthand, yet we absolutely know is pulling the strings because we watch it tug on everything else. Roughly 27% of the entire cosmos is composed of this mysterious phantom known as dark matter. This bounces back absolutely zero illumination. Because it completely ignores the electromagnetic spectrum, it remains eternally cloaked from our most cutting-edge lenses and sensors. Our only clue that this shadowy substance is lurking out there comes from watching ordinary glowing matter react to its invisible grip. Take spinning galaxies, for instance. They whirl around at speeds so reckless they should tear themselves apart if only visible stars were holding them down. Or look at massive galactic neighborhoods, which stay glued tightly together by an intense gravitational force far stronger than what their glowing gas and stars could ever generate alone. Then there is the ultimate cosmic funhouse mirror: gravitational lensing. When we see distant starlight dramatically warped and magnified as it passes heavy regions of space, it proves there is a hidden, massive bulk warping the fabric of reality itself. This phantom material acts like a hidden skeleton, forming colossal invisible spheres around galaxies to keep their whirling stars locked safely in orbit. Our very own home, the Milky Way, is swallowed by one of these shadowy bubbles, stretching way out into the dark, far past the farthest glowing suns. That unseen cocoon actually outweighs every single star in our cosmic neighborhood put together, packing anywhere from 5 to 10 times as much weight. Which brings up a wildly unsettling fact. You and I are wading through an ocean of this unseen stuff at this very second. Our blue planet, our sun's neighborhood, and our entire sprawling galactic home are completely submerged in this deep cosmic fog. Yet our instruments remain entirely blind to its touch. It glides effortlessly through physical objects like a ghost passing straight through a solid brick wall. The ultimate mystery? Science still has no clue what this phantom material actually is. The best guess right now is that it is built from exotic microscopic building blocks that completely ignore light and magnetism. They only answer to the pull of gravity and, maybe, just barely, to the quietest atomic forces. Nothing else. If this is true, an endless rain of these alien pieces is pouring down all around you, phasing straight through your skin, bone, and the deep crust of our world, silently piercing everything in existence, billions of them raining down every single second, without us ever batting an eye. To catch these ghosts, researchers have buried incredibly sensitive traps miles below the Earth's surface, hiding them under mountains of solid rock to block out noisy space radiation and stray signals, hoping against hope that just one of those phantom droplets will finally crash into a normal atom and ring the alarm. Yet, after tens of years of staring into the pitch dark, the ultimate identity of the universe's greatest ghost remains completely unsolved. Still, dark matter behaves like physical stuff. It carries weight and pulls things with its gravitational grip. We can actually calculate and track its influence. But what about the other 68% of the cosmos? That is where things get truly bizarre. Enter the ultimate cosmic ghost: dark energy. It is a phenomenon that completely baffles us. Yet it is the very engine driving the universe to expand at breakneck speeds. Back in the 1920s, the legendary astronomer Edwin Hubble realized our cosmos was physically stretching out. Star cities light years away are literally fleeing from our vantage point, and their retreat speeds up the deeper into the void you look. This revelation completely shattered our understanding of reality. It proved that space had an absolute dawn, an ancient instant where all existence was packed into a microscopic, endlessly dense spank before violently bursting open. That spectacular ignition is what we famously call the Big Bang. For generations, scientists naturally assumed this cosmic ballooning had to be losing steam, simply because gravity always tries to drag things back together. The collective tug of every galaxy, star, and rock out there was supposed to work like a giant set of brakes, steadily putting a halt to that outward rush. The burning scientific debate back then was whether the cosmos packed enough sheer mass to slam on the brakes completely, ultimately dragging reality back into a catastrophic collapse, or if it would just stretch outward forever at a decaying pace. Then came 1998, when a pair of rival research teams observing far-off exploding stars stumbled upon something utterly jaw-dropping. The cosmic stretch was not hitting the brakes at all. It was slamming on the gas. Our universe is flying apart far swifter today than it did in ancient times, and that pace is only getting wilder. This curveball was so shocking and went so hard against conventional physics that experts initially blamed faulty equipment. Yet, the math proved bulletproof. Reality is ballooning at an ever-increasing clip, powered by an invisible anti-gravity engine that actively forces the void apart. We labeled that phantom force dark energy. We have no clue what it actually is, nor can we build a machine to touch it. Our only proof of its existence is the way it radically stretches the fabric of the cosmos. The most elegant theory suggests this unseen force is simply a built-in feature of emptiness, a unique type of invisible power that thrives in the vacuum. Therefore, as the void grows, so does the volume of this phantom power, dramatically amplifying its outward push. And because cosmic inflation breeds more emptiness, the fuel supply multiplies, creating an unstoppable snowballing explosion of space that will last for eternity. What this really means is that a total enigma dictates the fate of our reality. This mysterious force accounts for roughly 68% of the entire cosmic pie. Meanwhile, the unseen phantom mass takes up another 27%. That leaves the normal, tangible elements, the very building blocks of our bodies, along with every glowing sun, rocky world, and swirling galaxy out there, accounting for a measly 5%. Every single thing humanity has ever looked at or touched is basically a microscopic footnote in the grand scheme of reality. Therefore, comprehending the sheer size of the cosmos is not merely an exercise in measuring miles. It is a humbling realization of just how terribly blind we are to the actual machinery of existence. Imagine tiny insects crawling along the shore, trying to map out the Pacific. We can definitely count the grains of sand beneath our feet. We might notice the tide rolling in, and we absolutely master the tiny patch of ground we stand on. Yet, the overwhelming abyss of the deep waters remains utterly invisible and impossible for our fragile minds to grasp. Now, let us shrink that perspective down to a scale that feels like home. Right this second, you are planted somewhere on a blue marble, soaking in this story, spinning on a rock that measures exactly 12,742 kilometers from edge to edge. Have you ever truly considered our place in the dark? We spend our days endlessly circling a blazing stellar furnace 1.3 million times our size, drifting roughly 150 million kilometers away. And yet, that massive sun of ours is merely a single glowing grain of sand among hundreds of billions scattered across the spiral arms of the Milky Way. Zoom out further, and our entire galactic neighborhood, known as the local group, holds roughly 50 similar island universes. That entire cluster? just a microscopic fraction of the Laniakea supercluster, which itself is merely one out of millions of colossal cosmic webs webbing across the observable cosmos. But brace yourself, because all of those glittering structures, every single thing our telescopes can capture, accounts for less than 5% of the actual stuff and dark energy making up reality. Viewed through this unimaginable lens, our homeworld practically vanishes into statistical zero, and our entire solar neighborhood follows suit. Our mighty Milky Way? A phantom. Even the sprawling Laniakea, holding 100,000 galaxies, registers as nothing more than a momentary dust mote. Even the most gigantic cosmic architecture we have mapped to date, those sprawling bridges of dark matter spanning billions of light years, are ultimately just trivial brushstrokes on a canvas we cannot even fathom. Yet, right here is where we hit a stunning contradiction. For a rock that feels so utterly meaningless against the backdrop of eternity, our world carries an unimaginable weight. To our current knowledge, this spinning blue sphere is the sole oasis of life in the eternal dark. Common sense, of course, whispers that this cannot possibly be the whole story. Surrounded by an ocean of countless suns and starry cities, the idea that we hold the only winning lottery ticket feels absurd. The very building blocks required to spark biology, your carbons, your hydrogens, your oxygens, along with nitrogen, phosphorus, and the rest, are scattered abundantly across the cosmic void. Whatever chaotic recipe of physics and chemistry ignited a pulse on our rock should theoretically be brewing in other planetary cauldrons. The real mystery we are chasing is simply a matter of cosmic frequency. Are the spiral arms teeming with millions of breathing, thinking ecosystems? Or is the spark so unbelievably fragile that only a solitary orb per galaxy ever wakes up? Could it be an even greater statistical miracle than that? The honest truth is, we are completely in the dark. Our robotic scouts have only just scratched the surface of our immediate backyard, and so far every single rock and crater we have sniffed out has come back completely sterile compared to our thriving biosphere. The red sands of Mars could very well conceal ancient microscopic fossils from a time when rivers flowed freely across its surface, but that smoking gun still eludes us. Then there are the frozen moons orbiting Jupiter and Saturn, specifically Europa and Enceladus, which hide massive, warm, saltwater oceans beneath miles of ice, waiting for our submarines to plunge into their alien depths. Look past the boundaries of our own sun's warmth, and astronomers have already cataloged thousands of alien worlds circling distant stars, featuring plenty of rocky globes perfectly positioned in that sweet spot where liquid water could comfortably pool without boiling or freezing. Yet, our current lenses simply cannot pierce their atmospheres deep enough to see if anyone is breathing the air. Therefore, until that paradigm-shifting day arrives, our home remains an absolute anomaly. It stands as the singular known arena where the cosmos eventually woke up, opened its eyes, and began to question its own existence. It is the one miraculous spot where stardust folded together over billions of years, building brains capable of peering through telescopes and deciphering the mechanics of the heavens. Let that sink in for a moment. That is nothing short of breathtaking. It is exactly this profound sentience that elevates our microscopic pebble into something of infinite worth. The legendary astronomer Carl Sagan captured this beautifully in his work Pale Blue Dot, describing our entire world as a mere speck of dust caught in a shaft of light. He was reflecting on a specific portrait snapped by the Voyager 1 probe back in 1990, looking back from a staggering distance of 6 billion kilometers. From that profound vantage point near the edge of our system, everything we have ever known registers as a faintly glowing azure smudge, taking up less than a single digital pixel against the endless void. Sagan poignantly noted that every hero and coward, every empire that rose and fell, every bloody conflict, And every tear of joy or sorrow throughout history played out entirely on that imperceptible pixel. It is a reality check that instantly shatters our egos, yet it simultaneously arms us with immense clarity. If we can truly wrap our minds around the terrifying majesty of space, if we can finally accept our dizzying smallness against a backdrop of endless infinity, we might finally wake up to the delicate, irreplaceable miracle of our fragile home. Perhaps then, we can strip away our trivial borders and arguments, realizing that we are just a single crew sharing the same fragile spaceship, sailing blindly together through a dark, freezing, and wonderfully terrifying cosmic ocean. Have you ever paused to wonder what the mind-bending size of our cosmos actually reveals? It holds a profound secret about the very fabric of reality itself. The cosmic truth is that existence is practically a void. The gigantic gaps stretching between celestial bodies completely dwarf the planets and stars themselves. Drill down to the microscopic level, and you will find that even atoms, the tiny Lego bricks of our reality, are absolute ghost towns. In fact, a single atom is roughly 100,000 times wider than its own core. Imagine magically squeezing out all of that inner emptiness, packing our entire Earth down to its absolute densest state. Our massive homeworld would shrink to a tiny sphere, just 180 meters wide. Apply that exact same squeeze to your own body, and every physical piece of you would easily balance on a pinhead. Yet you would not lose a single ounce of weight. It is a staggering thought. All your physical heft crammed into a microscopic speck. This architectural masterpiece of a cosmos is built like an endless set of Russian nesting dolls. Deep down, tiny quarks snap together to build protons and neutrons, which then fuse into the heavy hearts of atoms. Throw in some dancing electrons and boom, you have an atom. Those atoms link arms to create complex molecules. Molecules weave the intricate tapestries of living cells. And those cells team up to breathe life into breathing creatures. We creatures wander across planetary surfaces. Our rocky homes circle blazing suns, and those suns gather by the billions to light up sprawling galaxies. But it does not stop there. Entire galactic neighborhoods flock together into massive groups, which sweep themselves into unimaginable superclusters. Look even further out, and those superclusters weave the grand cosmic web of glowing filaments and colossal dark walls. Zoom out completely, and you hit the absolute edge of everything we can see, with the haunting possibility of an endless, infinite darkness stretching beyond. Yet, at absolutely every level of this grand design, nothingness reigns supreme. The dead zones rule the cosmos. Solid stuff is a cosmic anomaly, and physical structures are the rarest jewels. But here is the magic. Tucked away in those scarce, tiny pockets of matter, brilliant chaos unfolds. You get breathing biology, self-awareness, sprawling human societies, and the sheer audacity to look up at the night sky, ask how it all works, and actually decode the cosmos itself. So, what happens next? Grasping the grand size of space naturally forces us to wonder where this whole cosmic ride is taking us. Right now, our reality clocks in at 13.8 billion years old. To a fleeting human lifespan, that feels like an absolute eternity. But in the grand cosmic calendar, the party has barely started. Fiery engines like our own sun will keep blazing away for eons to come. Our local star has roughly 5 billion good years left in the tank before it finally burns through its hydrogen stash and swells up into a monstrous red giant. As the eons roll by, those much tinier celestial bodies, known as red dwarfs, which actually make up most of the stellar population, will slowly simmer for trillions of years. The absolute smallest among them could easily keep their fires lit for 10 trillion years or more. But the tragic truth of astronomy is that every single light in the dark will eventually flicker out. Birthing a new sun takes fresh fuel, mostly pristine hydrogen and helium, and that cosmic gas tank is slowly running dry. Every newborn star cooks those raw ingredients into much heavier metals. When the giant heavyweights end their lives in spectacularly violent supernova explosions, they blast those cooked elements deep into the void, seeding the dust clouds that will eventually spark the next generation of light. However, this recycling program is far from perfect. Massive amounts of material get permanently trapped inside cosmic graveyard relics, fading white dwarfs, ultra-dense neutron stars, and light-swallowing black holes. Other vital gas pockets get violently kicked right out of their host galaxies forever. Fast forward enough, and the universe will completely drain its reserves, losing the ability to forge anything new. Cosmologists predict the stellar baby boom will hit its absolute limit within the next trillion years, before entering a slow, dark decline. Hit fast forward 100 trillion years, and the universe's star-making factories will shut their doors for good. Reality will then cross the threshold into a twilight zone scientists call the degenerate era, a cold, quiet epoch where the only things left floating in the dark are dead, ghostly remains of a bygone age. White dwarfs will slowly freeze into black ice, while crushed neutron cores serve as tombstones for long-dead supernovas. And brown dwarfs will drift aimlessly, failed cosmic engines that never even gathered enough strength to catch fire in the first place. But what happens to reality when its ultimate traps finally die? Consider those terrifying cosmic sinkholes we call black holes, bizarre warps in the fabric of space where the gravitational pull is so intense that absolutely nothing breaks free. Yet, looking far enough ahead, even these ultimate survivors are doomed to break down. Take protons, for example, those fundamental building blocks anchoring every atomic core. Physicists suspect that, given an absurdly long wait, they actually fall apart. Modern calculations hint that these tiny pieces have a lifespan spanning roughly 10 to the 34th power years. To visualize that, picture the digit 1 trailing 34 zeros behind it. Should this hold true, once the cosmic clock hits 10 to the 40th power years, virtually every solid object in existence will dissolve into pure energy. At that stage, our grand cosmos will be reduced to a ghost town, inhabited purely by dark voids and incredibly scattered light waves. Fast forward even deeper into the future, and those gargantuan gravitational monsters will slowly bleed away through a phenomenon known as Hawking radiation. The legendary physicist Stephen Hawking proved that these cosmic traps actually have a slow leak. Thanks to some strange quantum quirks happening right at their edges, they constantly sweat out microscopic amounts of energy. This energetic leakage is almost unimaginably weak. For a void weighing exactly as much as our sun to completely vanish, you would have to wait roughly 10 to the 67th power years. Meanwhile, a galactic giant packing 1 billion times that mass would require a staggering 10 to the 100th power years to finally blink out of existence. Once that mind-bending milestone of 10 to the 100th power years is reached, reality plunges into what we call the dark era. Every single stellar engine will have permanently gone cold. Physical substance as we know it will be erased, and those bottomless gravitational wells will have entirely vanished. What remains is merely a freezing, ultra-thin mist of scattered light particles and lone subatomic drifters, endlessly stretching out into the void. With the fabric of reality relentlessly tearing outward, the ambient heat will plunge straight down toward absolute zero. Galaxies, planets, and atoms will be a distant memory, stripped of any intricate designs or dynamic shifts. All that is left is an infinite stretching of nothingness, plunging into an endless freeze, a phenomenon scientists grimly refer to as the cosmic heat death. Based on the strict laws of thermodynamics and our best astronomical models, this is the final curtain call for reality. Everything sparked to life in a phenomenal explosion we call the Big Bang. For 13.8 billion years, that initial spark has been shifting, growing, and organizing itself. We still have trillions of years of cosmic evolution ahead of us, yet the clock is ticking toward an absolute standstill. Eventually, entropy wins the ultimate victory. Energy becomes perfectly, uniformly diluted, rendering any future activity totally impossible. Now, picturing that bleak finale can definitely feel a bit disheartening. However, keep in mind that the spans of time we are dealing with here completely shatter human comprehension. 10 to the 100th power years is a duration that our brains simply cannot compute. To put that staggering figure into perspective, everything we know has only existed for a comparatively brief 1.4 times 10 to the 10th power years. This grand freeze is scheduled to occur a mind-boggling 10 to the 90th power times further into the future than the entire past timeline of creation. We are talking about the number 1, dragging 90 zeros behind it. No mind could ever genuinely wrap its head around an abyss of time that vast. Plus, here is the silver lining. This entire gloomy forecast relies entirely on the scientific rulebook we use today. If human history proves anything, it is that a single breakthrough can flip our entire worldview upside down. Just 100 years in the past, the concepts of dark energy and an inflating cosmos were completely unheard of. The weird rules of quantum mechanics and the warping of space were still mysteries waiting to be unraveled. Who can even guess what groundbreaking truths we will uncover over the next 100 years or the next 1,000 years? Discoveries that might entirely rewrite the final chapter of our cosmic story. Still, looking purely through the lens of modern science, the true magnitude of existence is not just about the endless stretches of observable space. It is the unfathomable depths beyond our horizon, potentially continuing forever, and the trillions upon trillions of years still to come. As reality morphs through countless bizarre epochs yet to unfold. Have you ever paused in the quiet of this exact moment to wonder what you actually belong to? Right now, you are breathing on a single, lonely globe circling a solitary sun, adrift in a staggering 13.8 billion-year-old cosmos. Yet our milky neighborhood is just one shimmering speck packed into a massive celestial crowd. That crowd links up into an immense chain of galaxies, weaving together like a glowing cosmic spiderweb that spans everything we can possibly see. And past the absolute limits of our vision, an endless dark ocean likely continues stretching on forever. Calling this space enormous is a massive understatement. It defies the very concept of size. Its sheer magnitude constantly shatters our mental boundaries, leaving our imaginations completely overwhelmed. Sure, we can crunch the equations and scribble out strings of endless zeros. We might draw maps or build tiny desktop versions, but our minds simply were not wired to picture infinity. We evolved to navigate a much cozier, bite-sized world. Our biology is trained to judge distances in simple footsteps, or perhaps the span of a continent, say a few thousand kilometers. We frankly possess no mental framework for distances measured in light chasing through the void for billions of years. Nor can we picture cosmic bridges 10 billion light-years long, holding trillions of glowing galactic islands. Even with those biological blind spots, the sheer power of human reasoning breaks through the barrier. Through persistent observation and precise calculations, we have stitched together the hidden rules governing reality itself. We hurl robotic messengers across the dark vacuum to uncover the icy and rocky secrets of our neighboring planets. We construct giant mirrored eyes that peer through billions of light years, functioning as literal time machines catching ancient echoes of light. Astonishingly, we have drawn incredibly detailed blueprints of the macrocosmic architecture. By analyzing the faint, cooling embers left over from creation, we managed to calculate exactly how old existence really is. We even feel the invisible tremors in the fabric of space itself, triggered by massive dark titans violently crashing together across billions of light years. This profound capacity to decipher the riddles of the starry canopy above, to pinpoint our incredibly fragile footprint within an intimidating abyss, marks humanity as a cosmic miracle, elevating our humble blue marble into something utterly irreplaceable. Based on current evidence, this floating rock is the sole sanctuary where the cosmos has grown a mind to ponder its own existence. Let that profound truth sink in. You are literally the universe gazing into a mirror. Every single microscopic building block flowing through your veins was cooked inside the fiery hearts of ancient suns that exploded billions of years in the past. You are, quite wonderfully and scientifically, walking ash from long dead stars. These scattered remnants drifted wildly through the frozen interstellar ocean for countless eons, crashing together by pure chance to forge entire worlds, oceans, and atmospheres, until they finally arranged themselves into you, a highly aware creature equipped to interrogate the dark sky and drag answers into the light. That fact alone is nothing short of breathtaking. It injects a beautiful sense of purpose into a cold, uncaring void. While the terrifying dimensions of reality stretch far beyond human sanity, and our world feels like a micro-dust mite, virtually invisible against the backdrop of infinity, this tiny rock remains our sanctuary. It served as the singular cradle where biological chemistry sparked, giving birth to self-awareness. It is the launch pad from which we engineered massive observatories, sleek rockets, and powerful digital brains. Right here in the dirt, we cracked the code of gravity, unraveled stellar anatomy, and realized our reality was constantly stretching outward. Looking upward at those impossible distances should absolutely strip away our arrogance. It puts our microscopic physical stature and the fleeting blink of human history into harsh perspective, reminding us that we are marooned on a tiny island with so much ocean left unseen. Yet this realization ought to ignite a fire in our souls. For creatures confined to an isolated pebble swirling in a chilling emptiness, our intellectual conquests are simply astounding. We actually took a cosmic tape measure and charted the borders of creation. We rewound the clock all the way to the violent, fiery dawn of everything. We mathematically mapped out its eventual doom, all while hunting down alien worlds orbiting distant alien suns. We felt the gentle splashing of space-time rippling out from cosmic violence billions of light years away. And incredibly, humanity achieved all these milestones in just a few hundred years of rigorous modern inquiry. Just picture the jaw-dropping mysteries we are destined to unravel in the coming centuries, or even the next few millennia, as our journey into the dark unknown is only just beginning. Could we eventually discover that we are not alone among the stars? We could engineer magnificent vessels capable of piercing the interstellar veil, or finally crack the enigmatic codes of dark matter and dark energy. Could we finally piece together the ultimate cosmic puzzle, seamlessly merging quantum mechanics with general relativity? Perhaps we will even construct a brilliant escape hatch from the inevitable burnout of our host star, safeguarding human civilization for billions of years into the distant future. Then again, the exact opposite could be true. We stand on the precipice of wiping out our own species before we even leave the cradle. Our profound inability to conquer existential threats, whether a rapidly warming climate, atomic warfare, or colossal asteroid strikes, could easily be our undoing. Humanity might forever remain marooned on this solitary rock, just a microscopic fleck suspended in an infinite void, completely unable to breach the boundaries of our local celestial backyard. This agonizing uncertainty is precisely why grasping the sheer magnitude of the universe is so deeply important. It forces a humbling perspective upon us, revealing our role in a magnificent tapestry that has been continuously expanding for 13.8 billion years and will keep unfolding for trillions more. This cosmic lens illuminates the unbelievable fragility of our globe, not because it holds any significant mass in the grand scheme of things, but simply because it is our one true sanctuary. It remains our only refuge, and based on everything we currently understand, it could be the singular oasis in an endless desert where biology thrives, where minds have awakened to self-awareness, and where intelligent creatures gaze upward into the night, desperate to decipher their ultimate purpose within the great cosmos. Trying to picture the immense span of space is completely mind-boggling, and frankly, it is designed to be exactly that. These astronomical distances are meant to utterly shatter our everyday common sense, demanding a radical shift in how we view reality itself. However, letting that staggering vastness crush your spirit or breed hopeless nihilism is the entirely wrong takeaway. Instead, it should ignite a fierce sense of awe, an absolute marveling at the sheer volume of creation that surrounds us, awe at the incredible amount of knowledge our species has already unlocked, and an intense excitement for the mysteries still waiting out in the dark. All of these profound realizations culminate in the grand narrative we have journeyed through in this episode, an epic tale beginning right here on the dirt beneath our feet, blasting outward past the orbits of our planetary neighbors, sweeping entirely through the Milky Way, the local group, the Laniakea supercluster, and into the absolute unknown, stretching our minds from the cozy and familiar to the wonderfully absurd. We have uncovered the deeply unsettling truth that the vast majority of our universe is entirely hidden from human eyes. It is a ghost world woven from dark matter and dark energy, invisible forces we can mathematically prove, yet never physically witness. Furthermore, this narrative stretches far beyond the boundaries of physical dimensions to encompass the very flow of time itself, spanning from the explosive dawn of the Big Bang 13.8 billion years in the past, all the way to the freezing, silent heat death waiting trillions upon trillions of years ahead. It exposes a startling reality. Highly organized physical structures are incredibly rare out there. The cosmos is overwhelmingly comprised of absolute nothingness, making every single atom, planet, and galaxy a spectacular anomaly. Yet beneath all the astrophysics, this is ultimately our story. It is the tale of how a fragile species dwelling on a microscopic speck of dust managed to map out an expanse so staggeringly huge it ought to be completely beyond mortal understanding. It highlights our incredible triumph in calculating the seemingly infinite, charting the uncharted voids, and making sense of absolute chaos. It is a testament to how human awareness, relentless questioning, and the brilliant tools of the scientific method have empowered us to gaze deep into the cosmic abyss, perceive its true nature, and carve out our own meaning within it, allowing our brains to wrap around the universe's true proportions, even when those proportions make us feel no bigger than a single grain of sand. Now, before we bring our stellar journey to a close, let us zoom in on a few remarkable cosmic landmarks. Grounding these massive concepts in actual specific examples is the perfect trick to help translate these mind-bending scales into something we can vividly picture in our heads. Imagine stepping just outside our planetary front porch and slowly traveling deeper into the dark, building a mental map, layer by layer, until the true grandeur of space finally clicks into perfect focus. Take the Alpha Centauri system, our sun's closest stellar neighbor. Picture a spectacular cosmic dance where three separate blazing suns are gravitationally locked in an intricate waltz. The two main actors, Alpha Centauri A and B, furiously swirl around one another as a tight-knit binary duo. Have you ever imagined a sky with multiple suns? Picture two massive stellar giants locked in a cosmic dance, completing a full circle around their shared gravitational anchor every 80 years. Then there is Proxima Centauri, the nearest neighbor to our own solar system at just 4.24 light-years out, which sweeps around that central pair on a vastly wider path. Unlike our blazing yellow star, this cosmic neighbor is a dim, chilly red dwarf. Yet it hosts a minimum of two alien worlds. One of these intriguing exoplanets, known as Proxima b, cruises right through the Goldilocks region, meaning its surface could potentially hold oceans of liquid water. But how hard is it to actually get there? Even with our modern rocketry, a trip to this neighboring system would drag on for tens of thousands of years. Consider the legendary Voyager 1 probe, the most rapid human-made object currently escaping our cosmic backyard. It zips through the void at roughly 61,000 kilometers per hour. Yet even at that blistering pace, a voyage to Proxima would consume an astronomical 73,000 years. To put that into perspective, that time span eclipses our entire written history, stretching back further than the dawn of farming itself. In fact, it is a duration longer than Homo sapiens have walked the Earth as a recognized species. And remember, this is literally our next-door neighbor. Out of billions of glowing spheres, this one sits right on our planetary doorstep. The vast majority of the glittering lights hanging in our local interstellar neighborhood are exponentially more distant. Take Sirius, the most brilliant diamond in the evening sky. That beacon shines from 8.6 light-years across the dark. Or consider Betelgeuse, the monstrous crimson giant acting as the shoulder of the Orion constellation, hovering roughly 550 light-years in the distance. So when you step outside and gaze up at that reddish twinkle tonight, you are actually witnessing ancient photons that began their journey back in the year 1472. Right in the heart of the Renaissance era. That means those beams of starlight set off well before Christopher Columbus ever navigated toward the Americas. These mind-boggling gaps of emptiness between local celestial bodies are actually completely standard for the Milky Way. Out here in the flattened disk of our galaxy, you will typically find about 5 light-years of sheer nothingness buffering each glowing orb. Think of it as the standard zoning law for stars. While a handful huddle closer and others drift further, a 5 light-year gap is the general rule of thumb. However, if you venture inward toward the galactic core, the stellar real estate gets incredibly crowded, with neighboring suns squeezing together into incredibly tight clusters separated by merely 1 or 2 light-years. Conversely, if you travel out to the galactic halo, the ghostly, scattered outer shell of our cosmic island, you will find stellar loners drifting in extreme isolation, physically divided by vast chasms spanning tens or even hundreds of light-years. Meanwhile, our own planetary system is hurtling around the heart of the galaxy at a dizzying 828,000 kilometers per hour, requiring anywhere from 225 to 250 million years just to complete a single grand lap. We are comfortably parked 26,000 light-years out from the core, which is fortunate because the absolute center of our galaxy is a brutally extreme and ferocious environment. Lurking right at the dead center is Sagittarius A star, a monstrous, supermassive black hole packing the gravitational punch of 4 million of our suns combined. Naturally, this cosmic behemoth is invisible to human eyes, since its gravitational grip is so severe that not even a single photon of light can break free. Yet, scientists can watch nearby stars whipping around an invisible focal point, and by analyzing those frantic trajectories, we can precisely weigh the unseen monster. A handful of these brave, blazing bodies dive dangerously close to the precipice of Sagittarius, a star. One specific object, simply named S2, slingshots through a full revolution in a mere 16 years. During its most terrifying plunge, it skims within 17 light hours of the abyss, roughly equivalent to the gap between our Sun and the ice giant Uranus. While riding that razor-thin edge of destruction, the star accelerates to a mind-bending 3% of the speed of light, a velocity so absurdly fast that the bizarre time-bending physics of relativity actually become visible. Astrophysicists have successfully observed these precise space-time distortions, tracking the celestial body's warped path to beautifully validate the exact theories mapped out by Albert Einstein over a century ago. The gravitational whirlpool surrounding this supermassive void is practically overflowing with blazing gas giants, packed together far tighter than anything we see in our quiet sky. Millions of radiant orbs are crammed into a tiny sphere spanning just a handful of light years, all tearing through the darkness at breakneck velocities, constantly swerving and executing terrifyingly close flybys. This frenzied, claustrophobic war zone is the absolute polar opposite of the peaceful, predictable cosmic suburb our Earth calls home. Out there in the core, the universe is a majestic, unforgiving, and utterly deadly spectacle. What would happen if we could magically teleport our pale blue dot right into that cosmic mosh pit? Well, for starters, the intense energy blasting from that crowded stellar neighborhood would completely fry our planet, wiping out all life in an instant. On top of that, the chaotic gravitational tug-of-war from those zooming suns would shred our solar system apart, likely flinging worlds like ours out into the cold, dark void forever. But let us step back from that extreme galactic core for a moment and take a look at the grander picture of our home galaxy. You see, this vast cosmic city is actually built out of a few very distinct neighborhoods. First up is the thin disk, a flat plane measuring roughly 1,000 light years across, which houses the vast majority of stellar residents and those iconic swirling arms. And naturally, this lively downtown district is exactly where our own sun hangs its hat. Wrapping right around that is the thick disk, reaching out roughly 3,000 light years both above and below our flatter home region. This area is basically a cosmic retirement community filled with ancient, fading suns that have a completely unique chemical makeup compared to our neighborhood. This massive difference in their atomic recipes tells us they were born during a totally separate chapter of our galaxy's epic origin story. Right in the very middle of everything sits the bulge, which is essentially a giant glowing sphere packed tightly with suns. This massive, glowing heart pushes out about 10,000 light years in every direction, acting as another haven for the galaxy's most ancient residents. Finally, pushing way out past the central glow, we find what astronomers call the halo. This is an incredibly vast, ghost-like bubble, stretching anywhere from 100,000 to 200,000 light years away from the galactic core. Out in these quiet suburbs, you will find scattered ancient suns, along with globular clusters, which are basically incredibly dense balls packed with hundreds of thousands of stars, floating right alongside massive, invisible clouds of dark matter. Now, have you ever wondered what those beautiful swirling arms actually are? They are definitely not solid objects. Instead, they act more like ripples of cosmic energy, squishing stardust and roaming suns close together for a short while before releasing them back into the void. To wrap your head around it, just picture a massive traffic jam during rush hour. Vehicles drive into the packed area, hit the brakes for a bit, and eventually hit the gas once the road clears up. That bottleneck stays in the exact same spot on the highway, even though brand new cars are constantly flowing right through it. And the galaxy operates the exact same way. Wandering solar systems and nebulas drift into these densely packed zones, hang out for an epoch or two, and then cruise right back out into the open space of the galaxy, leaving the swirling shape completely intact, despite its constantly rotating cast of characters. When you look at our cosmic home from above, you would spot four massive, sweeping bands, along with a handful of smaller, faded offshoots. Right at this very moment, our tiny solar system is cruising through a quiet gap between two of those giant bands, resting comfortably inside a minor splinter known as the Orion Spur. Humanity's neighborhood has been drifting through this specific cosmic off-ramp for millions of years, and we are not moving out anytime soon. However, way down the road, our cosmic trajectory is going to plunge us head first into one of those super densely packed main bands before tossing us back out into another empty, quiet gap. It is a never-ending cosmic roller coaster ride that repeats every single time our sun makes its massive 225 million year lap around the galactic core. But what lies beyond our own borders? Let us take a peek at the other cosmic cities sharing our corner of the universe. The heavyweight champion of our local cluster is none other than Andromeda, sitting roughly 2.5 million light-years in the distance. But do not get too comfortable, because it is currently barreling straight toward us at a terrifying 110 kilometers per second. Fast forward roughly 4 billion years from now, and these two gargantuan titans are going to smash together in a spectacular cosmic dance, eventually fusing into a giant, blob-like supergalaxy that scientists lovingly refer to as Milkdromeda. If anyone is still around to look up, the view from Earth is going to be completely unrecognizable. That tiny blurry smudge you can barely see through a telescope right now is going to swell to epic proportions until its breathtaking, glowing tendrils completely swallow the entire night horizon in spectacular detail. As these galactic behemoths finally crash, immense shock waves will violently crush massive clouds of cosmic dust together, sparking a huge explosion of stellar births. Billions of freshly ignited baby suns will set the heavens ablaze, looking like brilliant sapphire and diamond fireworks bursting all throughout the chaotic, swirling wreckage of the two merging galaxies. Yet, despite this unbelievably violent cosmic car crash, the chances of two actual suns crashing into one another is practically zero. The staggering amount of empty blackness between every burning sphere is so incomprehensibly massive that you could compare the entire event to tossing a couple of tiny pinches of sand at each other in a giant stadium. Every single little speck of dust is just going to glide effortlessly past the others, never even making a scratch. And the exact same rule applies to the billions of individual suns out there. When these massive star cities ghost right through one another, a physical crash between two suns is almost impossible. Instead, the real chaos comes from an immense gravitational tug-of-war that violently bends their cosmic paths, flinging countless blazing spheres into completely unfamiliar orbits around a newly formed galactic core. Then there is the stunning triangulum spiral, sitting as the third heaviest heavyweight in our local cosmic neighborhood, resting roughly 2.7 million light-years from Earth. While it might look puny next to our home galaxy, hosting a relatively modest 40 billion shimmering suns, it is actually locked in a permanent gravitational dance with Andromeda. Meaning when the great collision with our Milky Way finally begins, this third wheel will likely be dragged right into the fray, sparking an unimaginably chaotic three-way cosmic pileup. But our cosmic backyard is also littered with dozens of much tinier galactic neighbors. We call these dwarf galaxies, and they hold anywhere from a few million to a few billion stars, making them mere specks compared to the main trio. Have you ever looked up from the southern hemisphere and noticed two glowing, cloudy smudges? Those are the Large and Small Magellanic Clouds, which are actually misshapen, miniature galaxies locked in a continuous orbit around our own Milky Way. The larger of the pair sits roughly 160,000 light-years out in the void, packing around 20 billion blazing stars. Meanwhile, the smaller companion trails behind at 200,000 light-years away, carrying a much lighter payload of just 3 billion suns. Right now, our home galaxy is acting like a cosmic predator, using its immense gravity to slowly rip these tiny neighbors to shreds. If you could see the invisible, you would notice massive rivers of stolen gas and runaway stars stretching all the way from those clouds directly to us, serving as the ultimate proof of a slow-motion galactic dismantling. Fast forward several 100 million years into the future, and both of these glittering companions will be completely swallowed up, with their alien suns folding seamlessly into our own night sky. This brutal recycling process is simply how the universe works. The galactic giants only get bigger by feasting on the weak. Our very own Milky Way is a seasoned cannibal, having devoured dozens of smaller systems over the eons, with plenty more meals still on the menu. But what happens if we zoom out even further? Looking past our local neighborhood toward the colossal Virgo supercluster? Today, scientists call this staggering structure Laniakea. Translated from native Hawaiian, it means immeasurable heaven. And honestly, no title could be more perfect. This absolute behemoth holds an astonishing 100,000 individual galaxies, sprawling across a jaw-dropping 520 million light-years of empty space. To put that in perspective, that is over 5,000 times wider than our entire Milky Way galaxy. Imagine shrinking our entire galaxy down to the size of a tiny silver dime, measuring just 18 millimeters wide. On that exact same scale, Laniakea would span a staggering 94 meters across. That is roughly the entire length of a professional football field. Yet, this cosmic titan is nowhere near being a perfectly round sphere. Instead, think of it as a brilliantly flattened disk, radiating long, glowing tendrils that reach deep into the dark unknown. Every galaxy inside hangs suspended in an intricate cosmic web, clumping tightly along those bright threads, while carving out impossibly huge, empty dead zones in between. And nothing here is sitting still. It is a massive, rushing river of star cities, constantly drifting through the cosmos, dragged by unseen gravitational forces toward the heaviest, most crowded pockets of the universe. Sitting right at the center of this incredible current is a mysterious hotspot 250 million light-years away, known as the Great Attractor, an area packing an insanely powerful gravitational punch that bends everything around it. This unseen beast is reeling in thousands of entire galaxies like fish on a line. And yes, our home is caught on the hook too. As we speak, we are hurtling toward this mysterious destination at a terrifying speed of 600 kilometers every single second. Yet, incredibly, an even more terrifying giant lurks in the shadows behind it. Far past the Great Attractor sits a mind-numbing pile of cosmic mass named the Shapley Supercluster, brooding out in the void roughly 650 million light-years from Earth. This monstrous cluster houses over 8,000 gargantuan galaxies, cementing its status as one of the absolute heaviest, most densely packed physical structures within our observable universe. So what do these impossibly huge superclusters, cosmic walls, and gravitational titans actually teach us? They prove that the cosmos is not just a chaotic, random scattering of cosmic dust. It is a beautifully crafted masterpiece, brilliantly organized into a breathtaking hierarchy that scales up from tiny planets to blazing suns to massive galaxies, expanding all the way into mind-bending superclusters and endless cosmic walls. Have you ever wondered what invisible sculptor carved out the cosmos? The answer is gravity. This universal force gathered scattered stardust, weaving a perfectly smooth ancient void into the breathtaking, tangled, cosmic spiderweb we gaze at every night. Let us travel back to the dawn of creation. Exactly 380,000 years following the Big Bang, The cosmos was a nearly flawless, smooth soup of particles. Yet, hidden within that smooth expanse were microscopic ripples, imperfections of just 1 part in 100,000. However, those incredibly faint whispers of difference were all the universe needed to get started. Think of it like a cosmic snowball effect. Areas packed with just a little extra dust wielded a slightly heavier gravitational pull, dragging in neighboring material and swelling exponentially in size. Scientists refer to this relentless snowballing as gravitational instability, and it is the master architect behind the grand tapestry of our universe. To see this blueprint, we look at the cosmic microwave background. Imagine a glowing fossil, the primordial afterglow of the Big Bang, giving us a perfect snapshot of the cosmos in its infancy. By plotting this ancient light across our night sky, astronomers uncover faint shifts in temperature that perfectly match those original microscopic clumps of matter. The warmer patches reveal where matter was crowded together, while the chillier zones point to wide, empty spaces. These ancient temperature ripples acted as the cosmic seeds that blossomed into everything we observe out in the dark. Every single galaxy, along with their massive swarms and staggering superswarms and colossal galactic barriers, they all sprouted from those faint, ancient whispers of gravity. Now, let us embark on a journey to witness the absolute titans of the known cosmos. Consider the Sloan Great Wall, a behemoth spanning roughly 1.37 billion light-years from end to end. Picture a brilliant, glowing ribbon woven entirely out of whole galaxies, a celestial string that spans more than 1% of the entire observable cosmos. But this ribbon is not entirely flat. The stellar neighborhoods within it lie at varying depths, giving the structure an immense three-dimensional volume. Imagine it less as a simple line and more as a vast, shimmering membrane of starlight draped across the dark abyss. It measures hundreds of millions of light-years thick and trails out for well over 1 billion light-years in length. Then there is the CFA-2 Great Wall, a spectacular colossus unveiled back in 1989. Stretching 500 million light-years long and 200 million light-years wide, this giant houses tens of thousands of starry islands. Amazingly, the Virgo supercluster, the celestial backyard containing our very own Milky Way, is attached to this very formation, meaning we physically reside inside one of the most majestic neighborhood grids ever charted. Yet, the Hercules Corona Borealis Great Wall utterly dwarfs all of them. This mind-bending entity, provided it is truly a unified formation, extends an unfathomable 10 billion light-years across the void. To put that in perspective, it swallows up more than 10% of the entire observable universe. Astronomers managed to track down this Leviathan by tracing the explosive flashes of gamma-ray bursts, which are cataclysmic detonations triggered when dying supermassive suns violently cave in on themselves. Because these brilliant blasts outshine almost anything else, they act as cosmic lighthouses, allowing researchers to map out the deepest edges of the stellar wilderness. However, the very existence of this Hercules monolith stirs up fierce debate among stargazers. A handful of skeptical scientists argue it might just be a cosmic optical illusion, a lucky clustering of disconnected star groups rather than a true unified empire. But if it turns out to be real, it utterly shatters our current understanding of the cosmos. You see, an ironclad rule known as the cosmological principle dictates that on a grand enough scale, the universe is supposed to look perfectly uniform, no matter where you point your telescope. Under those laws, absolutely nothing should ever grow larger than 1.2 billion light-years. Yet this immense star wall blasts past that scientific speed limit by a factor of 8. Finding such an impossibly huge phenomenon implies one of two terrifying realities. Either our golden rule of cosmology is completely shattered, or we truly know nothing about how the universe was actually built. And lurking out there, Wedged between these unimaginably vast highways of starlight lie the chilling, pitch-black deserts we call the cosmic voids. Have you ever tried to imagine absolute nothingness? Back in 1981, astronomers stumbled upon the Boötes Void, a massive, ball-shaped pocket of space spanning roughly 330 million light-years that is practically deserted. In a normal patch of the cosmos this size, you would spot around 2,000 glittering galaxies, yet this colossal dead zone holds maybe 60. We are talking about a cosmic neighborhood that is 97% emptier than the universal average. Now, it is not a perfect vacuum, but it is breathtakingly barren compared to the rest of the cosmos. Imagine waking up stranded right in the dead center of this colossal abyss. You would have to travel over 150 million light-years in any direction just to reach the nearest major galactic cluster. Looking up, your night sky would be an endless ocean of pitch black. You might catch a handful of ghostly, barely there smudges hovering at the very edge of the void, but nothing more. There would be no magnificent glowing river of stars arching overhead like our Milky Way. You would see zero neighboring galaxies without a telescope, left entirely alone with the dark and the invisible cosmic microwave background. That invisible energy is just the ancient, fading echo of the Big Bang itself. And this is not just a one-off freak occurrence, as our universe is completely riddled with these staggering pockets of nothing. Take the giant void located in the Canes Venatici constellation, which stretches a mind-boggling 1.3 billion light-years wide. Then there is the CMB cold spot, an unusually freezing patch hidden within the Big Bang's afterglow, which scientists suspect hides an absolute monster of a supervoid. If true, that means there is a gap spanning an unimaginable 1.8 billion light-years of pure emptiness. Monstrous gaps like these severely test everything. We thought we knew about cosmic evolution and how incredibly massive structures could possibly form since the dawn of time. To really grasp this, we need to zoom out and look at the grandest picture possible. Once we chart every visible galaxy and place them onto a three-dimensional map, a stunning, intricate design suddenly reveals itself. It turns out everything is strung together in a breathtaking cosmic web. You will see sprawling threads of galaxies reaching across hundreds of millions, even billions of light-years, linking together massive hubs. These hubs act like grand cosmic intersections where brilliant clusters of galaxies gather in huge numbers. Trapped between those glowing threads are the voids, acting like gigantic desolate air bubbles. Picture a giant cosmic kitchen sponge, or a towering pile of sea foam. The glittering galaxies basically make up the delicate, soapy film wrapping around these vast pockets of nothingness. But this majestic sponge-like structure did not just happen by chance. It is the beautiful consequence of gravity tugging on the smooth, even soup of matter that existed at the very beginning of time. When astrophysicists run high-powered digital simulations of the cosmos, starting with microscopic ripples from the early dawn of reality, and letting gravity sculpt them over 13.8 billion years, the resulting digital universe looks virtually identical to the one we actually live in. These supercomputers perfectly recreate those glowing threads, the bustling intersections, and the chilling voids, matching our reality perfectly. But these models also reveal a mind-blowing secret. The vast majority of the physical stuff out there is not actually locked up inside galaxies. It is hiding entirely within those stretching threads, taking the shape of invisible dark matter and incredibly thin gas. Think of galaxies as nothing more than shiny beacons highlighting where those massive invisible structures lie. Imagine looking at Earth at night. The galaxies are like glowing cities strung along a dark interstate highway. The highway itself, made of that invisible dark matter and gas, is the true structural backbone of the universe. The bright city lights are merely the spots where material clumped tightly enough to ignite into stars we can actually witness. Ultimately, this means that when we gaze out at this majestic cosmic web, when we marvel at those intricate, glittering maps of celestial threads and endless dark bubbles, we are completely blind to almost everything out there. The brilliant star cities we admire hold a mere 10% of all normal matter. The remaining 90% is drifting through those cosmic highways as ghost-like gas, running far too hot and stretched way too thin to ever birth a single twinkling star. But what about the invisible elephant in the cosmic room? That is dark matter, packing roughly 5 times the bulk of everything we can actually see. Picture a vast, unseen spiderweb stretching across the cosmos. Normal matter simply drifts along these invisible silk threads, steered entirely by their hidden gravitational pull. But let us pull back for a second and dive into some figures that will absolutely melt your brain. Just think about the iconic snapshots from the Hubble Space Telescope. Those ultra-deep field images proved that when you stare into a pitch-black, seemingly empty patch of the night sky, you are actually staring at thousands upon thousands of entire galaxies, hiding right there in the dark. Tally up every single glowing sun inside all of those cosmic neighborhoods, and you reach a mind-bending figure. Roughly 200 billion trillion stars. Picture a 2 trailing 23 zeros. Having trouble wrapping your head around that? Well, imagine counting them, one by one, every single second. No breaks, no naps, just relentless counting. You would be ticking away for roughly 6 quadrillion years. To put that in perspective, our entire cosmos has only been around for a measly 13,800,000,000 years. You would have to keep going for 435,000 times the total lifespan of reality just to count every star we can see. Now consider that practically every single one of those fiery spheres hosts its own collection of orbiting worlds. Modern deep space scans tell us that planets actually outnumber the stars they circle. We are looking at an average of maybe 1.5 to 2 worlds per sun, and likely far more than that. Do the math, and that is a staggering 300 billion trillion planets swirling around out there in the observable dark. A good chunk of these cosmic marbles sit right in the Goldilocks sweet spot. Not too hot, not too cold, where liquid oceans could splash against alien shores. You have your solid, rocky spheres, just like our own home. You have swirling gas behemoths akin to Jupiter, and frozen, icy realms reminiscent of Neptune. Yet, buried within that astronomical haystack, there have to be billions, if not trillions, of perfect Earth twins. So the ultimate question is, do any of them hold life? The honest truth is, we are completely in the dark, since our blue dot is the only success story we know. Is biology a universal guarantee, or a bizarre cosmic accident? We have no clue is the perfect storm that sparked our existence, is happening everywhere, or, basically, a statistical miracle. Still, with an infinite casino of planetary roulette wheels spinning, it is incredibly hard to believe we are the only winners. Let us say just 1 out of every billion Earth twins manages to brew up microbes. That pessimistic guess still leaves us with hundreds of billions of living, breathing worlds scattered across the night sky. But how many of those alien microbes evolve into beings that can actually look up and wonder? Once again, we draw a blank. Here on Earth, basic single-celled organisms showed up to the party pretty early, popping into existence within the first billion years or so. But building complex, multi-celled creatures? That was a sluggish process, dragging on for about 3 billion years before anything interesting happened. And tech-savvy city-building intelligence? That is just a blip in the last few 100,000 years. A literal microscopic fraction of our world's story. This might mean brain power is exceedingly rare, requiring a chaotic lottery of evolutionary flukes. Or, conversely, it might be the unavoidable destiny of any planet, where life manages to take hold. We are completely flying blind. All of this beautiful mystery is mathematically bundled up into what scientists call the Drake equation. It is a famous formula cooked up by astronomer Frank Drake way back in 1961. It attempts to guess how many alien neighbors we could theoretically call up right now, looking at variables like the birth rate of fresh suns. It also factors in the slice of stars hosting planets, and how many of those are sitting in that cozy, habitable sweet spot. Add in the odds of those worlds spawning life, then upgrading to intelligence, and so forth. Plug in. If you wear rose-tinted glasses and run the numbers, you might find we are sharing the Milky Way with thousands, perhaps even millions, of other advanced civilizations. Are we sitting alone in an empty cosmic theater? Some of the gloomiest math actually suggests we might be the solo act. Yet this massive, deafening silence echoing through our giant dish antennas is exactly what we call the Fermi paradox. The name, he casually dropped that mind-bending question while grabbing lunch with his buddies back in 1950. Think about it. If our Milky Way is basically a bustling city of advanced empires, why is our cosmic inbox completely empty? The truth is, we have dozens of guesses. Perhaps getting intelligent life to spark is just a freak accident. Or maybe they pop up all the time, but burn out like a cheap firecracker, wiping themselves out before they ever figure out deep space travel. It's entirely possible they're out there chatting right now, using tech that makes our radio dials look like ancient smoke signals. Perhaps they're just buried too deep in the stellar ocean for our tools to catch them. Or worse, they're intentionally playing cosmic hide-and-seek. The raw truth? We have zero clue. Yet, solo or not, the sheer mind-melting size of outer space is enough to give you vertigo. If we do have neighbors hiding out in the dark, they are battling the exact same brutal physics rulebook that keeps us trapped. The empty voids stretching between glowing suns are like impossibly vast, uncrossable deserts. Jumping ships between different star systems, assuming it isn't just pure science fiction, would eat up hundreds or thousands of years, even if we strapped rockets onto our ships that pushed right up against the speed of light. Trying to text your buddies across the cosmos is completely bottlenecked by the universe's absolute speed limit. Shooting a quick hello to our closest stellar neighbor takes 4.24 years just to land on their doorstep. And you'd wait another 4.24 agonizing years just to hear a reply. Once you aim for suns further out in the deep black, that frustrating lag time stretches into absolute eternity, which creates a chilling reality. Even a galaxy packed to the brim with thriving empires still acts like a massive prison, locking everyone in solitary confinement through sheer distance alone. Hopping casually from one solar neighborhood to another just isn't on the menu. Sure, they can launch messages into the dark, but those agonizing wait times completely destroy any hope of a snappy real-time chat. Every single intelligent species is essentially trapped on its own lonely little island, staring longingly through the glass at a sparkling sea of untouchable planets, fully aware they can never actually visit. Now, let's plunge into something far weirder: the invisible ghost haunting our cosmos. We know for a fact that dark matter is out there. The sheer weight of its gravitational footprints makes it impossible to ignore. But what the heck is this invisible cosmic glue? Scientists' top suspect is a bizarre family of microscopic specks they call WIMPs, a brilliantly geeky acronym for weakly interacting massive particles. If these theoretical tiny phantoms exist, they would carry real physical weight, yet they only ever play ball with gravity. Or perhaps they share a tiny, faint, subatomic nudge with other things. They completely ignore light, refusing to glow, swallow it, or bounce it back, which turns them totally invisible to our most powerful lenses. They would phase right through solid walls, planets, and even your body like we were nothing but empty space, explaining perfectly why our high-tech traps keep coming up empty. But even after dozens of years hunting them, scientists are actively chasing down other bizarre suspects. Enter axions, a totally different flavor of theoretical cosmic speck, weighing barely a fraction of a WIMP, yet swarming our universe in mind-boggling, unimaginable numbers. Then you have primordial black holes, ancient, tiny gravity wells born right at the literal dawn of time, rather than popping up from the explosive deaths of crushed stars, adding another wild card to the suspect list. Or here is a massive plot twist. This invisible mass could be something so totally out of left field, an entirely unseen force or freak of nature, that human brains literally haven't even dreamed up yet. Regardless of its true secret identity, this unseen stuff acts as the ultimate, indispensable skeleton holding our entire cosmos together. If you magically erased it from history, the majestic, swirling star cities we see today simply would never have been built. The weak tug of normal, visible gas and dust just didn't pack enough raw muscle to clump the earliest stellar neighborhoods together fast enough on the cosmic clock after the universe exploded into being. This shadow substance acted like a heavy cosmic anchor, throwing in the extra gravitational muscle needed to violently kickstart the birth of galaxies. These invisible clouds actually caved in on themselves first, carving out massive unseen sinkholes that eventually dragged glowing gas and stardust right down inside them. Every single shimmering galaxy you look at through a telescope is effectively resting on an immense, hidden bedrock of this shadow material. It wraps around star systems like a giant, invisible bubble, stretching millions of miles past the bright, glowing edges we can actually see. Have you ever wondered what invisible ghosts haunt our cosmic neighborhood? The unseen shroud around our home galaxy stretches well over 200,000 light-years out into the void, completely dwarfing the glowing disk of stars we actually see by a factor of 2. Think of this hidden behemoth as a cosmic anchor, outweighing absolutely everything else. It tips the cosmic scales far heavier than every shining sun and swirling dust cloud clumped together. Right this very second, as our world dances around the sun and our solar system wheels around the galactic core, we are wading through an invisible ocean. Everything we know is constantly plowing right through this hidden soup of mysterious phantom particles. But if you think that is wild, let me introduce you to its even weirder cousin, a truly baffling force, taking up roughly 68% of everything that exists. This invisible powerhouse dominates the cosmos. It easily eclipses both regular stuff and its shadowy counterpart, acting as the invisible engine making the fabric of reality stretch outwards faster every single day. While that familiar force that keeps our feet on the ground acts like a cosmic glue, this mysterious phenomenon acts like a giant spring pushing everything away. And as the gap widens, the pushing gets exponentially more aggressive. The easiest way scientists wrap their heads around this is by imagining it as a built-in feature of the void, an inherent stretchiness to reality that experts label as the ultimate background hum of the vacuum. When we zoom all the way down into the bizarre realm of subatomic physics, we find out that pure nothingness is actually incredibly busy. Picture a boiling pot of water, but instead of bubbles, tiny specks of reality are sparking to life and vanishing in the blink of an eye. Those fleeting sparks hold actual power, which just might be the very fuel driving our runaway cosmos. Here is where the math totally falls apart, though. When the brightest minds crunch the numbers on this background fizz, the result is a staggering 10 to the power of 120 times bigger than what telescopes actually show us. Just imagine writing a single digit followed by 120 zeros. An absolutely mind-bending figure. It stands as the single most embarrassing miscalculation in the history of science, where the chalkboard totally betrays the telescope. We are either dealing with a catastrophic flaw in how we understand reality, or some unknown cosmic eraser is wiping away almost all of that power. leaving behind just the faintest whisper. At this point, the entire scientific community is completely stumped. Yet, the undeniable truth remains. Reality is ballooning outward at a terrifying, ever-increasing pace. Neighboring star cities are sprinting away from our vantage point, hitting the gas pedal harder as time ticks on. Down the line, after many billions of years have passed, anything outside our immediate cosmic neighborhood will race away quicker than their glow can reach us. Their colors stretched until they blink out entirely. Like ships sailing off the edge of a flat horizon, they will vanish from the night sky piece by piece, until the only things left to admire are the few neighboring star clusters permanently tethered to us by gravity. The grand tapestry of the cosmos will look totally barren, leaving merely a handful of glowing islands floating in an endless, pitch-black ocean. This chilling fate paints a profoundly lonely picture for what lies ahead. Imagine a species waking up to consciousness in that distant epoch. Trillions of years into the future, they will inherit a night sky entirely stripped of its majesty. Peering through their telescopes, they will spot only their immediate galactic neighbors, utterly oblivious to the massive web that once existed. The ancient afterglow of creation itself will be completely hidden from their instruments, stretched so incredibly thin and washed out that not a single sensor could pick up its faint whisper. The sweeping superclusters and deep cosmic voids that we map today will be absolutely invisible to them. Those future stargazers will logically assume their tiny pocket of stars is the absolute boundary of existence, which means you and I happen to be alive during an incredibly privileged era in the grand timeline. We actually have front row seats to observe the echoing heat of the universe's fiery birth. We get to watch distant celestial cities drift away and clock their exact getaway speeds. Our generation gets to chart the majestic spiderweb of the cosmos, holding the smoking gun of creation and witnessing the ultimate stretching of reality.